At exactly 11:27 in the morning on January 27, 1945, Second Lieutenant Makoto Ogawa banked his fighter left through thin air at 22,000 feet above Tokyo, watching four massive shapes crawling across the winter sky like steel whales. At 24 years old, he had 7 confirmed kills against American bombers, more than any pilot in his squadron, and he knew exactly how this would end. The B-29s looked slow and heavy, their 4 engines trailing black exhaust, and Ogawa could already see the gap beneath their tail where no gunner could reach, the same blind spot that had made him an ace against flying fortresses over the Philippines. His wingman radioed that they would dive from the sun, rake the bomber bellies with 20mm cannon, and be home for rice and tea by sunset. It was the kind of confident talk that had filled Japanese cockpits for 3 years, the same rhythm of attack that had worked against every American heavy bomber since Pearl Harbor. Ogawa pushed his throttle forward and began his dive, closing to 800 yards, then 600, watching his gun sight settle on the nearest bomber's fuselage. The American crews inside were probably cramped and freezing at altitude, manually swinging their .50 caliber guns like sailors working deck cannons, trying to track a fighter moving 3 times faster than their turrets could turn. At 400 yards, twin streams of tracer fire whipped past Ogawa's canopy with impossible precision. Not the wild spray he expected, but tight bursts that seemed to know exactly where he would be. His wingman exploded in a ball of orange flame before he could even radio a warning. The tracers were coming from guns that moved like they had eyes, tracking his every turn with mechanical coldness that made his hands shake on the stick. As he pulled hard right to escape, watching 2 more of his squadron mates spiral toward the ground in smoking pieces, one terrible thought cut through his confusion like ice water. These weren't the same bombers they had been fighting, and the Americans had taught their guns to think. The letter Lieutenant Makoto Ogawa wrote to his sister on the evening of January the 20th, 1945, carried the same confident tone that had filled his correspondence for months. "The American bombers are larger now, but they remain bombers," he wrote by candlelight in his quarters at Hamamatsu Airfield. "Our zero dances where their guns cannot follow. Tomorrow we hunt again." He folded the rice paper carefully, sealing it with wax that bore the imprint of his family crest, a diving hawk with outstretched talons. Outside his window, mechanics worked through the night, preparing his Kawasaki Ki-61 fighter, its engine cowling removed to reveal the Mitsubishi Ha-40 power plant that would carry him to 25,000 feet in tomorrow's intercept mission. Ogawa had earned his reputation, methodically studying American bomber formations with the patience of a scholar. 7 confirmed kills decorated his service record, each one a testament to precision rather than recklessness. Against the Boeing B-17 flying fortresses, he had perfected the art of the belly attack, diving from high altitude to strike the bomber's undefended underside, where the ball turret gunner's field of fire created a deadly blind spot. The technique required nerves and timing, but it worked with deadly consistency. His squadron leader, Captain Yamamoto, often used Ogawa's tactics in briefings, sketching attack angles on a blackboard, while younger pilots scribbled notes. The Americans had been bombing Japan's home island since June of 1944, but their patterns remained predictable. Heavy bombers flew in tight formations, relying on overlapping fields of defensive fire to protect individual aircraft. Japanese fighters exploited gaps in this coverage, striking from angles where gunners couldn't traverse their weapons fast enough to track a diving interceptor. Speed and surprise were everything. Get close, fire a concentrated burst into engines or fuel tanks, then escape before the formation's defensive guns could respond. It was aerial combat reduced to physics and geometry, velocity, angle of approach, and the narrow window of opportunity where hunter became hunted. On the morning of January 27th, Ogawa's squadron received orders to intercept a formation of American heavy bombers approaching the Tokyo Industrial District. Intelligence reports indicated 12 to 15 aircraft flying at altitude, probably targeting aircraft manufacturing facilities in the western suburbs. The weather was clear with unlimited visibility, perfect hunting conditions. Ogawa buckled his parachute harness and climbed into his fighter's cockpit, running through the familiar pre-flight checklist while ground crew pulled wheel chocks and cleared the propeller arc. Takeoff came at 10:45, 6 fighters climbing in loose formation through the thin air above central Honshu. The radio crackled with position reports and altitude calls as they gained height, their engines straining in the oxygen-starved atmosphere above 20,000 feet. Through his canopy, Ogawa could see the snow-covered peaks of the Japanese Alps stretching toward the horizon, their ridgelines sharp and clean in the morning light. Below, Cities and towns spread across the landscape like ink stains on rice paper, connected by rail lines that carried the industrial lifeblood of the empire. At 22,000 feet, the enemy formation appeared as dark specks against the winter sky. Ogawa counted the shapes through his gun sight: 4 heavy bombers in a loose diamond pattern, their 4-engine silhouettes, unmistakably American. But something was different about these aircraft. They were larger than the flying fortresses he knew, with broader wings and deeper fuselages that suggested heavier bomb loads and longer range. The engines left thick contrails in the frigid air, marking their passage like chalk lines on a blackboard. "Formation leader to all aircraft," Captain Yamamoto's voice crackled through the radio. "Attack pattern Delta, Ogawa-san, take the trailing bomber. Dive from the sun, strike the belly, egress south." The familiar rhythm of combat communications filled the frequency: call signs, headings, altitude assignments. Each pilot acknowledged his target and approach vector with the crisp professionalism that had carried them through dozens of similar engagements. Ogawa rolled his fighter into a diving turn, lining up his attack run on the rightmost bomber. The aircraft grew larger in his windscreen as he closed the distance. Definitely not a B-17. This machine was broader, heavier, more purposeful in its construction. Its wing loading suggested it could carry twice the bomb load of earlier American bombers, and its altitude capability was clearly superior. But the fundamental vulnerability remained. No bomber could defend its belly against a high-speed diving attack. Physics demanded it. At 1,000 yards, he could make out details of the bomber's construction. Gun turrets were visible in the nose and tail positions, but the distinctive ball turret that defended the B-17's vulnerable underside was absent. Instead, the bomber's belly appeared smooth and unbroken, a perfect target for his 20mm cannon. Ogawa's finger found the trigger, waiting for the optimal firing solution. 800 yards. 700. His gun sight settled on the bomber's fuselage just aft of the wing root, where fuel tanks and engines created the most vulnerable target area. The tracers appeared without warning, twin streams of .50 caliber fire that reached toward his fighter with impossible accuracy. These weren't the wild, desperate bursts he expected from manually operated guns. The fire was controlled, precise, almost deliberate in its targeting. Ogawa yanked his stick hard left, feeling G-forces slam him into his seat as the fighter responded. Behind him, his wingman's aircraft erupted in flames, pieces of wing and fuselage spinning away in the bomber's slipstream. More tracers followed his evasive turn, tracking his movement with a fluidity that made his hands shake on the controls. The guns weren't just shooting where he was, they were shooting where he was going to be. As he pulled out of his dive, climbing desperately for altitude and distance, 2 more fighters from his formation tumbled earthward in burning spirals. The radio filled with panicked voices calling for help, reporting hits, announcing bailouts. In 30 seconds of combat, half his squadron had been destroyed by defensive fire, more accurate than anything he had encountered in 3 years of war. Banking sharply toward home base, Ogawa looked back at the American formation. The bombers continued their steady progress. Toward Tokyo, their guns now silent, their formation intact. Whatever had just happened represented something fundamentally new in aerial warfare, a shift in capability that rendered his hard-won expertise suddenly obsolete. The confident letter he had written to his sister the night before now seemed like a message from another war, another world where courage and skill still mattered more than the cold precision of machines that could think. Staff Sergeant Tommy Kowalski sat in what Boeing engineers called the Central Fire Control Station, a pressurized compartment deep in the belly of the B-29 Superfortress city of Los Angeles. Unlike the cramped, freezing gun positions he had manned in B-17 flying fortresses over Germany, this station resembled the interior of a luxury automobile. Kowalski occupied a comfortable swivel chair upholstered in olive drab leather, surrounded by an array of analog computing equipment that hummed quietly in the conditioned air. Through a periscope-style sighting device, he could see the Japanese fighters climbing toward his formation at 22,000 feet, their wings glinting in the morning sun like silver needles threading through the sky. The General Electric Central Fire Control System represented the most advanced defensive weapons technology ever installed in a military aircraft. 5 separate sighting stations throughout the bomber fed targeting information to analog computers that calculated firing solutions with unprecedented precision. Unlike the manually operated guns of earlier bombers, where individual gunners aimed by instinct and experience, The B-29's defensive system treated gunnery as an engineering problem requiring mechanical solutions. Each computer weighed over 200 pounds and contained more than 3,000 precision machine parts, including servo motors, amplifiers, and mechanical calculators that processed dozens of variables simultaneously. Kowalski adjusted his periscope sight, centering the crosshairs on the lead Japanese fighter. The moment he activated the tracking mechanism, electrical signals flowed through miles of wiring to the bomber's remote turrets. His movements controlled 4 50-caliber machine guns mounted in the upper forward turret, but he never touched the weapons directly. Instead, servo motors translated his sight adjustments into precise gun movements, while analog computers calculated the complex ballistics required for accurate fire. The system compensated automatically for the bomber's altitude, airspeed, and heading, plus the target's range, bearing, and rate of closure. It even adjusted for outside air temperature, which affected bullet velocity, and parallax error caused by the physical separation between sighting station and gun turret. The engineering challenge had consumed General Electric's finest minds for 3 years. Traditional aircraft gunnery relied on human reflexes and judgment, but high altitude, combat demanded precision beyond human capability. At altitudes above 20,000 feet, where the B-29 operated routinely, air density was 60% of sea level normal. Bullets followed different trajectories in thin air, and temperature variations of 50 degrees below zero affected powder burn rates and projectile velocity. Human gunners, even experienced ones, could not compensate for these variables while tracking fast-moving targets through manually operated gun mounts. The solution was automation. Each analog computer contained mechanical calculators that solved ballistics equations in real time. When Kowalski tracked a target through his periscope sight, the computer measured the target's angular velocity and calculated its future position based on observed movement patterns. It then adjusted gun elevation and traversed to place bullets where the target would be when the rounds arrived, not where it appeared at the moment of firing. The entire process required no conscious input from the gunner beyond keeping his crosshairs on the target. The machine did the thinking. Sergeant Mike O'Brien occupied the tail gunner position in the same aircraft, controlling twin 50-caliber guns through an identical fire control system. His station featured the same leather chair and periscope sight, but his field of fire covered the bomber's most vulnerable approach angle. Previous American heavy bombers had relied on human tail gunners sitting in exposed positions, manually operating their weapons while enemy fighters attacked from behind. The B-29's tail gunner sat in the pressurized cabin, separated from his guns by 20 feet of aircraft structure, controlling them through electrical impulses and mechanical precision. The system's effective range exceeded anything previously achieved in aerial gunnery. Manually operated guns were accurate to perhaps 400 yards under ideal conditions. The B-29's fire control computers extended that range to 900 yards, creating a defensive envelope that forced attacking fighters to engage from distances where their own weapons lost effectiveness. Japanese fighters mounting 20mm cannon had maximum effective ranges of 600 yards, giving the B-29 a 300-yard advantage in opening fire. That margin often determined the outcome of aerial combat. Technical Sergeant Robert Chen monitored the system's performance from the flight engineer station, watching electrical gauges and servo motor indicators that told him when the defensive network was functioning properly. The central fire control system consumed enormous amounts of electrical power, requiring 2 dedicated generators and backup systems that automatically engaged if primary power failed. Chen's instruments showed him the status of each turret, the ammunition count for every gun position, and the operational condition of the analog computers that made precision gunnery possible. When enemy fighters approached, his job was to ensure that 900 rounds per minute of 50-caliber fire reached the right coordinates at exactly the right moment. The human element remained crucial, but in ways that previous bomber crews never experienced. Instead of individual gunners fighting separate battles from isolated positions, the B-29's crew functioned as a coordinated team, managing an integrated weapons system. Kowalski tracked targets and designated priorities, but the analog computers calculated firing solutions. O'Brien monitored the rear hemisphere while Chen ensured that electrical power and ammunition supplies remained adequate. The aircraft commander, Major William Hayes, coordinated defensive efforts with evasive maneuvering that gave his gunners optimal firing opportunities while maintaining formation integrity with other bombers. Training for the new system required months of specialized instruction that bore little resemblance to traditional gunnery practice. At Lowry Field in Colorado, gunners learned to operate periscope sights and understand the capabilities of analog fire control equipment. They practiced tracking aircraft models suspended from overhead cables, learning to trust mechanical calculators rather than human instincts when engaging targets. The transition proved difficult for experienced gunners accustomed to manual weapons. Many struggled to accept that a machine could aim more accurately than trained human reflexes, but combat results validated the technology's effectiveness. The B-29 program represented the largest single aircraft development project in American history, consuming more resources than the Manhattan Project that created atomic weapons. Boeing manufactured 3,970 superfortresses between 1943 and 1946, each one equipped with the revolutionary Central Fire Control System. The technology transformed defensive gunnery from an art practiced by skilled individuals into a science executed by precision machinery. When Japanese fighters encountered this system over Tokyo in January 1945, they faced opponents who could kill at distances and with accuracy that redefined the mathematics of aerial combat survival. The letter Lieutenant Ogawa wrote to his sister on February 3, 1945, carried none of the confidence that had characterized his earlier correspondence. "The sky has changed," he wrote with unsteady brushstrokes. "We climb toward death machines that see us coming from distances our fathers could not imagine. Yesterday I watched Tanaka-san burn alive while still 500 meters from his target. The Americans have made their bombers into flying fortresses that think." He sealed the letter but never sent it, instead burning it that evening in a small fire outside his quarters. Some truths were too dangerous to commit to paper, too demoralizing to share with civilians who still believed in ultimate victory. The psychological transformation of Japanese fighter pilots began with the first encounters over Tokyo in late January. Captain Isamu Kashide, the Imperial Army Air Force's most decorated B-29 killer, found his established tactics suddenly obsolete. His signature frontal attack, a high-speed dive directly at the bomber's nose to overwhelm defensive gunners before they could track his approach, no longer worked against the new American fire control systems. Where manual gunners had required precious seconds to swing their weapons and establish a firing solution, the B-29's automated turrets locked onto his fighter the moment he entered their defensive envelope. Tracers reached toward him with mechanical precision that made evasive action feel futile. Kashide's combat reports, filed with the 10th Air Division headquarters at Fusa Airfield, documented the fundamental shift in aerial warfare mechanics. Enemy defensive fire exhibits unprecedented accuracy at ranges exceeding 800 meters, he wrote after a February 7th engagement over Nagoya. Standard approach patterns result in immediate targeting by multiple turret positions operating with coordination impossible for human gunners. Recommend immediate revision of all established intercept doctrines. His superiors initially dismissed these reports as exaggeration born from combat stress, but mounting pilot losses forced acknowledgement that Japanese air defense faced an unprecedented technological challenge. The numbers told a story that words could not adequately convey. During January 1945, the Japanese Army Air Force recorded 43 fighter aircraft lost in combat with American heavy bombers, compared to 7 B-29s confirmed destroyed. February losses climbed to 61 Japanese fighters against 12 bombers shot down. By March, the casualty ratio had deteriorated to nearly 8-1 in favor of the Americans. Young pilots with minimal training were being fed into a meat grinder that consumed aircraft and aircrew faster than Japan's diminished industrial capacity could replace them. Lieutenant Hiroshi Yamada, age 19, flew his first combat mission against B-29s on February 15th over the Mitsubishi aircraft factory at Nagoya. His training had consisted of 40 hours in obsolete training aircraft, plus briefings based on tactics developed for fighting B-17 flying fortresses. None of his instructors had encountered the Central Fire Control System, so his preparation emphasized approaches that proved suicidal against automated defensive weapons. Yamada's squadron leader assigned him to attack the trailing bomber in a formation of 8 superfortresses, using the classic stern chase that had worked effectively against manually gunned aircraft. The engagement lasted 12 seconds. Yamada closed to 600 meters before defensive fire began tracking. His approach: unlike the scattered, poorly aimed bursts he expected from human gunners, the tracers converged on his fighter with deliberate precision. He attempted evasive maneuvers but found the guns following his every movement, leading his turns and anticipating his reactions. A .50 caliber bullet severed his rudder control at 400 meters. Another burst punctured his fuel tank and ignited vapors that filled his cockpit with smoke. Yamada bailed out over Sagami Bay, becoming one of 17 Japanese pilots shot down that day by B-29 defensive fire. The psychological impact extended beyond individual pilots to entire squadrons and air groups. Major Saburo Nakajima, commanding officer of the 53rd Sentai at Chofu Airfield, watched his unit's effectiveness disintegrate as experienced pilots were killed or wounded by defensive systems they could not counter. "Our young men climb bravely toward the enemy," he wrote in his private diary, "but they might as well be flying into the mouth of a dragon. The Americans have created weapons that kill with the patience of machines and the accuracy of gods." Morale plummeted as pilots realized that traditional courage and skill offered no protection against technology designed to eliminate human advantages in aerial combat. Intelligence reports from captured American aircrew revealed the extent of the technological disparity. Interrogated B-29 gunners described their work as like shooting ducks in a shooting gallery when Japanese fighters attacked using predictable approach patterns. The central fire control system gave them decisive advantages in range, accuracy, and target tracking that made defensive gunnery more akin to mechanical work than combat. Japanese intelligence officers struggled to comprehend how American bombers could maintain such devastating defensive fire while simultaneously carrying enormous bomb loads to targets deep inside Japan. Desperate tactics emerged from desperate circumstances. Some Japanese pilots began attempting ramming attacks, sacrificing their lives to destroy individual B-29s through direct collision. Others tried night attacks, hoping that darkness would neutralize the American fire control advantage. Captain Makoto Ogawa pioneered high-altitude intercepts from above, diving through bomber formations at maximum speed to minimize exposure to defensive fire. These techniques produced occasional successes, but required exceptional skill and luck that most surviving pilots lacked. The most telling indicator of demoralization appeared in pilot rotation requests and medical groundings for combat fatigue. By March 1945, nearly 30% of Japanese Army Air Force fighter pilots had requested transfer to other duties, while medical officers reported unprecedented rates of stress-related illnesses among aircrew. Flight training programs struggled to replace losses, but replacement pilots arrived at operational units, with minimal preparation for encounters with B-29 defensive systems. Letters home from surviving pilots painted increasingly grim pictures of aerial combat over Japan. Second Lieutenant Kenji Nakamura wrote to his parents after surviving 3 encounters with American bomber formations. "The enemy shoots at us with guns that never miss. We are samurai wielding swords against men with rifles. There is no honor in this death, only the grinding of machines that care nothing for courage or tradition." His letter was intercepted by military censors and never reached its intended recipients, but similar sentiments appeared in correspondence throughout the fighter-pilot community. The transformation was complete by April 1945. Japanese fighter pilots who had once approached American bomber formations with confidence now climbed toward them with resignation born from experience. The sky above Japan had become a technological battlefield where human skill mattered less than mechanical precision, and where courage could not overcome the cold logic of analog computers calculating death with unprecedented accuracy. Technical Sergeant James Rodriguez crouched beneath the nose turret of Lady Liberty at Northfield, Guam, holding a voltmeter against a maze of electrical connections that snaked through the B-29's forward fuselage like mechanical arteries. The central fire control system had failed during the previous day's mission over Yokohama, leaving the crew defenseless against Japanese interceptors for 43 terrifying minutes until Rodriguez jury-rigged a manual override using spare wire and electrical tape. Now 12 hours later, he was discovering why the world's most advanced defensive weapon system had nearly gotten them all killed. The problem lay buried deep within the analog computer that controlled the upper forward turret, a precision instrument containing over 3,000 individual components packed into a space smaller than a footlocker. One of the servo amplifier tubes had burned out during climb to altitude, creating a cascade failure that disabled gun tracking throughout the forward hemisphere. Rodriguez had located the faulty tube, but replacing it required dismantling half the fire control system, a job that would take 6 hours with proper tools and replacement parts. Northfield Supply Depot had neither the specialized tubes nor the technical manuals needed for repairs, forcing maintenance crews to cannibalize components from other aircraft or attempt field modifications that often created new problems. Master Sergeant William Chen, the squadron's senior fire control technician, supervised 3 maintenance teams working simultaneously on different B-29s, each aircraft suffering from distinct electrical failures that rendered their defensive systems partially or completely inoperable. The complexity that made the central fire control system so effective in combat also made it extraordinarily vulnerable to mechanical breakdown. Unlike manual gun turrets that functioned with simple mechanical linkages, the automated system depended on precise electrical coordination between dozens of components. A single failed relay could disable multiple turrets, while voltage fluctuations caused by engine RPM changes could throw off the analog computer's targeting calculations by several degrees. The maintenance burden had grown exponentially as B-29 operations intensified throughout early 1945. Aircraft returning from missions over Japan regularly reported fire control malfunctions ranging from minor tracking errors to complete system failures. Replacement parts arrived sporadically from the United States, often taking weeks to reach forward bases in the Mariana Islands. Meanwhile, combat crews faced the prospect of flying deep penetration missions over heavily defended targets with degraded or non-functional defensive capabilities. Staff Sergeant Robert Murphy, a former automobile mechanic from Detroit, found himself responsible for maintaining electrical systems more complex than anything he had encountered in civilian life. His training at Lowry Field had covered basic fire control operation, but combat conditions revealed problems that no training program could anticipate. High-altitude flight caused moisture condensation inside analog computers, creating short circuits that disabled targeting mechanisms. Vibration from engine operation loosened electrical connections, while rapid altitude changes caused expansion and contraction of metal components that affected calibration. Murphy spent most nights working by flashlight, tracing electrical faults through miles of wiring while aircraft commanders demanded their planes be ready for morning missions. The supply crisis extended beyond replacement parts to encompass basic maintenance equipment. Specialized test instruments needed for fire control calibration were in short supply throughout the 20th Air Force, forcing technicians to improvise solutions using equipment designed for other purposes. Oscilloscopes intended for radar maintenance became tools for diagnosing servo motor problems, while radio technicians' multimeters served double-duty checking fire control voltages. The improvised maintenance procedures often worked, but they consumed enormous amounts of time and skilled labor that could have been better utilized on other critical systems. Major General Curtis LeMay, commanding the 21st Bomber Command, received daily reports documenting the maintenance challenges that threatened to undermine B-29 operational effectiveness. His staff calculated that each superfortress required an average of 16 maintenance hours for every hour of flight time, compared to 8 hours for the B-17 Flying Fortress. The Central Fire Control System accounted for nearly 30% of that maintenance burden, despite representing less than 10% of the aircraft's total weight. LeMay's operations planners struggled to maintain sortie rates while dealing with chronic defensive systems failures that left bomber crews vulnerable to fighter attack. The human cost of maintenance failures became apparent during the February 19th mission against aircraft factories near Tokyo. Second Lieutenant Donald Walsh's B-29 Yankee Doodle lost fire control during the bomb run when a servo amplifier overheated, disabling all remote turrets except the tail position. Japanese fighters attacked from angles the single remaining gunner could not cover, killing the navigator and wounding 2 other crew members before the bomber escaped into cloud cover. Post-mission inspection revealed that the failed amplifier could have been replaced in 30 minutes if proper replacement parts had been available, but supply shortages forced maintenance crews to defer non-critical repairs until components failed completely in combat. Engineering officers at Wright Field in Ohio received urgent requests from Pacific commanders for simplified fire control systems that traded some capability for improved reliability. The complexity that made Central Fire Control so effective also made it maintenance-intensive under combat conditions, particularly at forward bases with limited technical support. Boeing engineers proposed modifications that would reduce component count and eliminate some of the system's more failure-prone elements, but implementing changes required months of testing and production modifications that could not be completed before war's end. By March 1945, LeMay had reached a radical conclusion about B-29 employment that reflected growing frustration with fire control maintenance problems. His analysis of combat losses indicated that Japanese air defenses were collapsing under the weight of sustained bombardment, reducing the need for heavy defensive armament. Simultaneously, his maintenance officers reported that fire control systems were consuming disproportionate amounts of technical resources while contributing less to mission success than originally anticipated. These factors led to his decision to begin low-altitude night incendiary attacks using B-29 stripped of most defensive guns in favor of increased fuel and bomb loads. The B-29B variant, introduced in limited numbers during spring 1945, eliminated the Central Fire Control System entirely, except for tail guns, reducing maintenance requirements by 40%, while increasing bomb load capacity by 3,000 pounds. Flight test results showed that the stripped bombers could operate at higher altitudes and greater speeds, making them less vulnerable to the remaining Japanese fighter defenses. LeMay's staff calculated that the simplified aircraft could complete missions with half the maintenance time required by fully equipped superfortresses, allowing higher, sortie rates with existing personnel and equipment. The irony was unmistakable to those who understood the technical details. The central fire control system had terrified Japanese fighter pilots and revolutionized aerial gunnery, but its complexity ultimately made it too expensive to maintain under combat conditions. American victory over Japan came not from technological superiority alone, but from the ability to adapt tactics and equipment to operational realities that revealed the hidden costs of advanced weapons systems. Lieutenant Makoto Ogawa sat in the ruins of what had once been the officers' quarters at Hamamatsu Airfield on August 20th, 1945, 5 days after Emperor Hirohito's surrender broadcast had ended the war. Around him lay the scattered debris of Japan's air defense, burned aircraft, abandoned equipment, and the personal effects of pilots who would never return home. In his hands, he held a letter he had written but would never send, its rice paper yellowed by smoke from the cooking fires that now provided the only heat in the damaged buildings. The words he had written captured a truth too painful for official histories. They were not demons flying those bombers, just men with better machines. But those machines taught us that courage alone cannot overcome cold precision. The final accounting of the air war over Japan revealed numbers that stunned both American and Japanese military analysts. United States Army Air Force's records credited B-29 gunners with destroying 914 Japanese aircraft during the strategic bombing campaign, with an additional 456 listed as probable kills and 770 damaged beyond repair. These figures represented the most successful defensive aerial gunnery campaign in military history, achieved by weapon systems that had transformed individual gunners into operators of mechanical killing devices. The central fire control system had rewritten the fundamental equations of aerial combat, making approach to American heavy bombers a calculated suicide mission that even Japan's most skilled pilots could rarely survive. Captain Isamu Kashidi, who had claimed more B-29 kills than any other Japanese army pilot, survived the war with 12 confirmed victories against the superfortresses, a record that cost him 2 aircraft shot from under him and wounds that left permanent scars across his back and left arm. In the quiet years that followed Japan's surrender, he often reflected on the transformation he had witnessed in aerial warfare. The confident young fighter pilot who had attacked his first B-29 in November 1944 bore little resemblance to the cautious, methodical survivor who flew his final combat mission in July 1945. The machines had taught him fear, but they had also taught him respect for technological precision that transcended national boundaries or military loyalty. Staff Sergeant Tommy Kowalski returned to his family's farm in Wisconsin in December 1945, carrying memories of 35 combat missions over Japan and the knowledge that he had personally directed the destruction of at least 6 Japanese fighters through the periscope sight of his central fire control station. The transition from technological warrior to civilian farmer proved more difficult than he had anticipated. The precision instruments that had made him deadly at 25,000 feet seemed irrelevant among cornfields and dairy cattle. But the experience of coordinating lethal machinery had changed his understanding of what humans could achieve when properly equipped with advanced tools. The post-war analysis conducted by both American and Japanese military historians revealed the broader implications of the B-29's defensive revolution. Traditional fighter tactics, refined through 4 years of aerial combat in Europe and the Pacific, had become obsolete almost overnight when confronted with automated fire control systems. Japanese pilots trained in methods that had worked effectively against B-17 flying fortresses found themselves helpless against weapons that could track their movements and predict their intentions with mechanical precision. The learning curve proved fatal for hundreds of aircrew who died trying to adapt human reflexes to challenges that demanded technological solutions. Technical Sergeant James Rodriguez spent the immediate post-war years working as a civilian contractor, helping Boeing engineers analyze maintenance data from Pacific Theater B-29 operations. His detailed logs documented the hidden costs of advanced weapons systems, the thousands of man-hours required to keep central fire control computers functioning under combat conditions, the chronic shortage of specialized replacement parts, and the extraordinary skill levels demanded of maintenance personnel. The lessons learned from B-29 defensive systems influenced the design of post-war military aircraft, leading to simplified systems that balanced capability with maintainability. The human dimension of technological warfare became clearer as veterans from both sides shared their experiences in the decades following Japan's surrender. American gunners described the surreal experience of killing enemy pilots they never saw directly, watching fighters explode or spin away in flames while they remained sealed inside pressurized compartments, manipulating periscope controls and electrical switches. Japanese survivors spoke of facing weapons that seemed to possess supernatural accuracy, making traditional concepts of aerial combat obsolete through the application of engineering principles to the ancient art of war. Major General Curtis LeMay's post-war memoirs acknowledged both the effectiveness and limitations of the central fire control system. While B-29 defensive gunnery had decimated Japanese fighter forces, the complexity and maintenance requirements of the automated systems had consumed resources that might have been better utilized elsewhere. His decision to strip defensive guns from B-29B variants reflected a pragmatic assessment that technological superiority must be balanced against operational practicality. The most advanced weapons system in the world was worthless if it could not be maintained under combat conditions. The broader lessons of the B-29's defensive revolution extended far beyond World War II, influencing military thinking about the relationship between technology and human performance in combat. The central fire control system represented an early example of human-machine integration that would become commonplace in later conflicts, where individual soldiers and airmen functioned as operators of complex weapons systems, rather than traditional combatants relying primarily on personal skill and courage. The transformation observed over Japan in 1945 foreshadowed a future in which victory would depend increasingly on technological advantages rather than traditional military virtues. In 1963, 18 years after the war's end, Makoto Ogawa met Thomas Kowalski at a veterans reunion in Honolulu, where former enemies gathered to share memories of the conflict that had defined their youth. The Japanese fighter pilot and American gunner discovered they had faced each other during the February 15th mission over Nagoya, when Ogawa's squadron had attacked Kowalski's bomber formation. Neither man could say with certainty whether they had directly engaged each other in combat, but both understood they had participated in a technological transformation that changed aerial warfare forever. Their conversation, conducted through interpreters and marked by mutual respect, captured the human complexity of conflicts where advanced machinery had replaced individual combat with mechanical precision that rendered traditional courage both heroic and tragically obsolete. The sky over Japan in early 1945 had become a laboratory where the future of warfare was written in contrails and tracer fire, where the meeting of human courage and mechanical precision produced lessons that would influence military thinking for generations to come.